Good morning, algebra students. This is Mrs. Crumpton, and today's lesson is 7-2, Division Properties of Exponents in your Glencoe Algebra 1 book. You can follow along pages 398 through 404. Your learning target: I can divide monomials using properties of exponents. I can simplify expressions containing negative and zero exponents. Again, I can divide monomials using properties of exponents, and I can simplify expressions containing negative and zero exponents. New vocabulary, which you can look up after viewing the video. Zero exponent can be found on page 399, negative exponent, page 400, and order of magnitude, page 401. Today's video lesson will not cover order of magnitude. We will do that in class the next day after you see this video. The material that we'll see covered today comes from the Content Standards A.SSE.2, F.IF.8b, and has to do with Mathematical Practices number 2. Your first example comes from page 398, and we are going to see an example with the quotient of powers. The quotient of powers says when you divide two powers with the same base that you simply subtract the exponents. Now I'm going to show you two different ways to do this, option number 1 and option number 2. If you don't understand the rule, which I understand, some of you may have problems with the rules, you can always write out what this means, what that fraction means, which is what I'm going to do with the first option. X to the 7th power means I have x multiplied by itself 7 times. And y to the 12th means y multiplied by itself 12 times. And I'm running over into option 2 here. So I'll have to do some erasing before we can see option 2. Oops, my y's are starting to look like x's. Okay, and then you do the same thing in the denominator. Okay, now with option number 1, which is the long way about doing this, you would cross out pairs in the numerator and denominator. So I have a pair of x's here. Everywhere you have a pair, you cross through a pair until you have something left. Same thing with the y's, crossing out pairs. That should be a y and not an x right here. Cross out those pairs, and then you count what you have left. Well, I only have ones. X over x would be 1. X over x would be 1. Right here, x over x. All of these pairs that I've crossed out would be 1. Anything over itself is 1. Okay, and I have an x left. So my answer here would be x, and then I count the number of y's I have left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer would be xy to the 9th. Okay, option 2, I'm going to do this up here, and I'm going to show you how to do this using the rule that you've been given right here. According to the rule, to divide two powers with the same base, we simply subtract the exponents. Okay, take a look here where we've got x over x, x to the 7th over x to the 6th. Well, according to my rule, I simply subtract those exponents. 7 minus 6 would be x to the first power. And since the 7 is a larger number, we leave that x in the numerator. Same thing with my y's. I subtract the exponents. 12 minus 3, and I have y to the 9th power. That got us to our answer a whole lot quicker than option number 1, which was writing everything down. Okay, students, here are 2 problems for you to try. I will let the video run for just a minute, and also we can pause the video and you attempt these 2 problems without any help. Okay, let's look at our answers. According to the rule, and I'm going to use the rule with these, we subtract the exponents. So I would have x to the 3 minus 2, y to the 4 minus 1. My answer, hopefully you got this, x to the first power, y to the third power, which anytime you have an exponent of 1, you can just leave that as the variable by itself, x, y to the third. Okay, students, the next problem that you had to try without me is k to the 7th power, m to the 10th, p, over k to the 5th power, m to the 3rd, p. Again, we subtract the exponents if we're using the rule, and we get k to the 7 minus 5, m to the 10 minus 3, p to the 1 minus 1. Okay, that gives us k to the 2nd, m to the 7th, p to the 0, which will bring us to the next concept we're doing. Anything raised to the 0 power is 1, so my answer is simply k to the 2nd, m to the 7th. Our power of a quotient rule is kind of something we've already looked at. Make sure that the exponent outside parentheses gets applied to everything inside parentheses, including what's in the denominator. So this particular problem would be 4 to the 3rd, c to the 3 times 3, which would be 9, d to the 2 times 3, which would be 6, and 5 to the 3rd power. And of course, when you can clean that up a little, you need to do so. 4 to the 3rd power would be 16 times 4 would be 4 to the 3rd power would be 64. C to the 9th, D to the 6th, over 125. Now, of course, if those coefficients, or in this case a constant in the denominator, if that could be reduced, you would need to do so. Also, if there was a C and a D of some power in the denominator, you would need to take care of that as well. Here are 2 problems for you to try. I'm going to let the video run for just a few seconds in silence, and you are to be trying these problems. If you need extra time, please pause the video. let's take a look at these problems. Here we would have 3 raised to the third power, x to the 4 times 3, which would be x to the 12th power, and also 4 raised to the third power. When you work this out, you would have 27 x to the 12th over 64. Next, there should have been an exponent of 2 outside of this. So that's my fault on that one. Just work along with me, please, and we'll finish this one up. 2 to the second power, of course, is 4. Y to the 2 times 2 would be y to the 4th. 3 squared would be 9. Z to the second power would be just that, z to the second power. Okay, I hope you understood those. If you do not understand them, please make sure that you make some kind of notation next to these so that you can ask me the next time we're in class together. As promised, in the previous one of the previous problems that we did when we had the p to the 0 power, now we are going to talk about the zero exponent property, which is very easy to understand. The words tell us any non-zero number raised to the 0 power is equal to 1. It gives you some examples there. 15 to the 0 power equals 1. b over c to the 0 power is 1. 2 over 7 to the 0 power is 1. Take a look at the examples here provided for you. As you can see, I have everything inside these parentheses raised to the 0 power. Well, that's real easy. According to your rule up here, when you have something in everything inside is raised to the 0 power, then your answer is simply 1. Now that was not too hard at all, was it? Okay, let's look at your next problem. We have m to the 0, which we know from this example, anything raised to the 0 power is 1. So m to the 0 is 1. Then I have that rule with the n's where I have an n to the third power in the numerator and an n to the second power in the denominator. The rule says that I subtract those exponents. So 3 minus 2, that would be n to the first power, or just 1n. Please make sure you get these examples in your note, and we may have another random note check here pretty soon. Next, we have the negative exponent property. Now, the main thing that you need to remember about negative exponents, and you can go back and watch that super base video, and it addresses negative exponents in that. When we finish a problem, unless the directions say to write with a negative exponent, you should not have any negative exponents left. Now, I teach this a little differently from how your book does on page 400. And I hope, 400 and 401 actually, I hope what I tell you makes sense, and if you will pay close attention, I believe that it will. If you take a look here, in the first example, I have x to the negative 4th. To make that negative 4th exponent become positive, I've got to cross that down to the denominator. Okay, and if you look, I also have in the denominator z to the negative 6th. I cannot have a negative exponent, so I need to cross that one up to the numerator. So when I do all that crossing, I'm left with y to the 9th. I've crossed my z up. that would be z to the positive 6th. And when I cross the y down, the z, excuse me, I'll get the right variable in a minute. When I cross the x down, that exponent changes to a positive. It's this simple. When an exponent crosses the fraction line, the exponent changes its sign. Again, when an exponent crosses the fraction line, the exponent changes its sign. Learn that rhyme. When an exponent crosses the fraction line, the exponent changes its sign. Last time, when an exponent crosses the fraction line, the exponent changes its sign. Okay, now let's look at the other example that I have here. We need to clean up these coefficients right here. We know that 15 will divide evenly into 75. 15 goes into 75 5 times. Now, since the larger number is in the numerator, my 5 will stay in the numerator. Okay, now, deciding which of these p's needs to cross, because we need to simplify that away. You can do it two ways. How we previously did, where we listed them out, p times p times p, over 5 times p times p times p times p times p, or you can subtract the exponents. And what you want to do is you want to take the exponent that is smaller across the fraction bar to the larger. That changes the sign of the 3 to a negative 3. When an exponent crosses the fraction line, the exponent changes its sign. So we have p to the 5th minus 3. Okay, next, again, we have an m in the numerator and denominator. We need to cross the smaller to the larger. And since negative 5 is smaller than negative 4, we're going to cross that down. And in the denominator, I have m to the negative 4. Since that exponent crossed the fraction line, it becomes positive 5. And finally, we have an r to the negative 8th in the denominator. That needs to become positive. So I'm going to cross that to the numerator, and my r to the 8th will now be positive. Now I got some cleanup work to do here. 5r to the 8th, p to the 5 minus 3, of course, p to the 2nd, and m to the negative 4 plus 5 would just simply be m. Okay? Think on this. Make sure you get your example written down. Make sure you understand what's going on with this. If you have questions, be sure you ask me when we're back together as a class. Here are two problems for you to try. These have to do with the zero property and with negative exponents. So I'm going to stop talking for just a few minutes and let you try these two problems. If you need additional time, then you may pause the video. Okay, let's look at what we've got. We've got b to the 4th, c to the 2nd, d to the 0 over b to the 1st, c. Okay, now cross those up, cross the smaller exponents up to the larger. In the numerator, we would have b to the 4 minus 2, c to the 2 minus 1, and d to the 0. Anything raised to the 0 power is what? I hope you said 1. So all of that would be times 1. So the 1 really doesn't make that much difference. We do need to clean up. 4 minus 2 is 2. 2 minus 1 is 1. Our answer b squared c. Next, we've got a whole bunch of negative exponents, and we need to make sure we get that cleaned up. First off, let's take care of our coefficients. 32 divided by 4 would be 8. Next, we cross the smaller exponent to the larger exponent. And when an exponent crosses the fraction line, the exponent changes its sign. So we have a to the 3 plus 8. Cross the smaller exponent to the larger. We have b to the 5 minus 3 in the denominator. Again, we're crossing the smaller exponent to the larger. So in the denominator, we have c to the negative 2 plus 4. My answer, 8, a to the 11th, b to the 2nd, c to the 2nd. How did you do on those problems? If you still have questions about these, make sure that you make yourself a note and ask me questions when we're back together. You need to master these exponent rules. And finally, we are down to order of magnitude. If you will preview order of magnitude, it is on page 401 and page 402. You'll see that that's a word problem that they have for you. I need you to look over those ahead of time. Be prepared for class, and I will go over examples for order of magnitude with you in class. Your assignment, these are your freebies, as I like to call them. Page 402, 1 through 17 odd. You may make corrections on these problems. I'm giving you the odds so that you can check your answers. If you miss any of these, please make sure you make note and bring them to class tomorrow. Corrections will be allowed on 1 through 17. Your heads-up assignment, which means I will be assigning this on the next day we're back in class together. You can also start on this after you have checked 1 through 17. Every other even problem on page 403. So you do an even problem, number 20, you skip 22 and go to 24. So please make sure after you have tried 1 through 17 odd and checked your answers, you can go ahead and be working on page 403, the every other even problem there. If you get to a word problem, skip that one until we get back together and can talk about order of magnitude. Thank you so much, and I look forward to seeing you back in class.